Okay, this is on literal equations, solving an equation for another variable. And on this problem, we're supposed to solve this equation for y. What I would do is first subtract the 2, and we get x minus 2 equals 3 halves y. Now multiply by the reciprocal of 3 halves, which is 2/3, and so we'd have to multiply both sides by the 2/3. That includes that whole side over here. The 2/3 cancels out the 3 halves next to the y, and we just get y equals 2/3 times x minus 2. On this problem, since the 5/9 is times the whole side, I can't add the 32 right off the bat because it's affected by the 5/9. So I could multiply by the reciprocal right off the bat, multiply by 9/5 on both sides, and I'll get 9/5 c equals, the 9/5 cancels out the 5/9, and I just get f minus 32. Now just add 32 to both sides, and you have your answer. Okay. On this third one here, we could divide both sides by -3 and then subtract 2. That would be a fine way of doing this. Or you could distribute the -3 through. It's not that difficult to distribute the -3 through compared to distributing the 5/9 through back on this problem. That would be pretty messy. But here it isn't too bad to just distribute the -3 through. You get -6y minus 6. Now you could move your minus 6 to the left and get x plus 6 and then divide through by -3, and that would be right. I try to get the y's to be positive, the variable I'm solving for, the coefficient in front of it, to be positive. So I move my minus 3y to the left and my x to the right. When I do that, I'll get 3y because I moved it to a different side. I added 3y to both sides, and I subtracted x from both sides to get 3y equals -x minus 6. Then just divide both sides by 3, and I would get -x minus 6, all that divided by 3. Now, that's fine, or I could break it up and say that's -x divided by 3 minus 6 over 3. And the reason you might want to do that is because 6 over 3 reduces down to 2. So this and this, they're all equivalent answers, and generally these are multiple choice type of answers that would be only written correctly one way, or if it was fill in the blank, all these would be correct. Okay, on this one, solving this for y, you could cross multiply right off the bat, thinking of this as being 3x over 1, and we would get 5x plus 6y equals 6x. That's just from cross multiplying. Now, let's subtract the 5x from both sides to get all my x's on one side, and I get 6y equals x. That's from 6x minus 5x. And then divide through by 6, and I get y equals x over 6. Now, in this problem, it's a little bit tough. We're going to solve this for y, and you'll see why it's a little bit tough. And first of all, you would take care of any fractions if there were any fractions, and there are. Next, take care of any parentheses if there were, and there's not. But what we need to do here is get like terms on one side. In fact, we want to get all the terms that have the variable we're solving for on one side. So all the terms that have a y, get them to one side, and all the terms that don't have a y, get them to the other side. If I do that, I'll get all my y's over to the left because most of them are all over there already. So I get 3xy minus 4y. I need to take this 2xy to the left, so that'd be minus 2xy equals, on the right hand side I got 8 minus x, and then I have to take this 6 over to the right, which will give me a minus 6. Now combine like terms, 3xy minus 2xy is just 1xy, minus 4y equals, on this side 8 minus 6 is 2 minus x. Now this is where it's very difficult for people to do this type of problem because you can't combine these, they're not like terms, but you can factor out a common factor of y, and if you do that, you're left with x minus 4. Okay, so I factored out a y, I'm left with x minus 4 when I factor that out, and you can double check that by multiplying the y back through. You get xy minus 4y, and that equals 2 minus x. Now get rid of this x minus 4. Well, it's times the y, so divide both sides by x minus 4, and that will be your answer to that problem. Okay, one more problem like that. This one, you could maybe cross multiply first, and we get Cn, or Nc, if you want to say it either way, is equal to n plus w. Now we're solving this for n, so get all the terms that have an n on it on one side, so I subtracted n from both sides to get Nc minus n equals w. And that's what we have over here. Nc minus n equals w. Now it's just like the last problem, we can't combine these, so factor out the variable that you're solving for, which is n, and if you do that, we would end up with n times the quantity, c minus 1. If you factor out or divide out an n, you're left with c minus 1. Multiply back through just to check. N times c is nc, and n times minus 1 is minus n. So n times c minus 1 equals w, and again these are multiplied, we're solving for n, so just divide both sides by the c minus 1, and you'll get your answer right here of n equals w over c minus 1. Now let's see if we have time to solve this problem. Okay, on this problem, it says first factor the denominators. So this one, I'll factor the 2 out of right here on the 2x minus 4. Factor out of 2 gives me 2 times the quantity x minus 2. There's a common factor of 3 there, so I factored that out. And this is a trinomial that factors into these two binomials. If you have trouble factoring things, you can use the polynomial sheet to help you factor trinomials. Now you need to multiply by the common denominator, and the common denominator needs a x minus 2, a 2x minus 3, and also a 6. So we need to multiply by the common denominator, and it looks really messy, but it's really not the end of the world.
Oh, Fuff, it's not like this is the end of the world as we know it.
This is the end of the world as we know it.
Well, maybe it is the end of the world. So here's what you do. When you multiply by the common denominator, you say, what's extra in the common denominator that's not in this denominator? Well, 2 goes into 6 3 times, so I'll need a 3. And also there's a 2x minus 3 extra up on the top. So that 3 and the 2x minus 3 needs to be multiplied times the 3, and that's what I have right there. What's extra in this common denominator that's not in this denominator? Well, 3 goes into 6 2 times, and there's also an x minus 2 that's extra in this common denominator. So I have to multiply this by 2 and the x minus 2, and that's times that numerator of 5. What's extra here that's not in here? A 6. So the 6 has to be multiplied times the 6x minus 5. Now, just take this 9, 3 times 3 is 9, and take that across, and 9 times 2x is 18x, 9 times minus 3 is minus 27. This is 10, take that across, you get 10x minus 20, and take the 6 through, and you get 36x minus 30. Okay, combining some like terms, 18x and 10x is 28x. Here's minus 27 minus 20 is minus 47, and that equals 36x minus 30. Okay, nothing to combine on the right-hand side. Now, let's get all of our x's on one side. And if I subtract 28x from both sides, I can keep the x's positive. You can move them either way, but I'm going to subtract 28x from both sides. And if I subtract 28x from 36x, I'll get 8x. And then I'll add 30 to both sides, get my numbers on the other side, and I'll get negative 17. And then finally, divide both sides by the 8, and I'll get x equals negative 17/8. And that's the answer to that problem. Now, this actually wasn't a literal equation, but it is an equation that Excel can't solve for you, so you would have to do this problem by hand. And that will wrap it up with this section.